Welcome to the Green IC Research Group at the National University of Singapore. In this video, we are happy to share about the first sub-microwatt fully integrated Wi-Fi backscatter transmitter with active image and harmonics rejection, which cleans its frequency spectrum as necessary in common dense wireless environments. Riwan will now share the details of the innovation introduced in this chip.
Hello, this is Riwan. Wireless environments are being increasingly denser in view of exponential growth in the number of connected and coexisting devices, making efficient and non-disturbed channel utilization a priority, especially in unlicensed bands such as 2.4 GHz. Meanwhile, pricing demand for lower power consumption has driven the recent evolution of backscatter transmitters, compiling with existing wireless standards. Unfortunately, backscatter transmitters traditionally suffer from spurious images and harmonics, polluting the frequency spectrum and degrading the overall wireless channel utilization. Our work proposed to improve the image rejection ratio through quadrature modulation and to partially improve HR by intermediate frequency overclocking to push out the harmonics out of the band, though costing more power and limiting channel selection. Even in this case, the harmonics are not mitigated due to the discontinuous phase in modulations used in Wi-Fi 802 11B. Thus, in this work, we propose a Wi-Fi backscatter transmitter with active rejection of both image and harmonics via complex filtering based on reflection coefficient modulation, while avoiding power-hungry intermediate frequency overclocking.
In the proposed architecture, the conventional power-hungry complex filter is greatly simplified through two key ideas. First, the phase approximation of the conventional Wi-Fi digital filter replaces adders and multipliers by a simple 8x8 lookup table, which reproduces the 8 samples temporal filter response for the 8 possible triplets of 3 subsequent input bits. Second, traditional and power-hungry synchronous logic eliminated by introducing an innovative time domain filter. Essentially, the temporal profile of the antenna reflection coefficient is updated by modifying the RF switch impedance of a programmable impedance bank at appropriate times, based on the timing set by a calibrated delay line. At each sample period, the latest 3 input bits digitally select one of the 8 complex response patterns, which in turn corresponds to different combination of 8 basic complex loads, Z, leading to the desired reflection coefficient. The corresponding impedance is generated by the programmable impedance bank. Temporal and process variation for impedance and delay lines are compensated via temperature event-driven self-calibrated reference. This is our test chip in 22nm FD-SOI technology. The proposed transmitter is based on the commonly adopted passive Wi-Fi backscatter communication scheme. The incident wave is sent by a tone generator and then reflected by the backscatter transmitter after proper reflection coefficient modulation. The reflected signal is centered at the desired channel and is directly demodulated by a commodity receiver. The received spectrum of backscatter signals reach the state-of-the-art image rejection ratio of 30 dB, which represents an improvement over the spur best by 12 dB. The 36 dB harmonic rejection ratio represents a 23 dB improvement over a baseline without active rejection.
Overall, the proposed backscatter transmitter has the best image and harmonic rejection ratio compared to the prior art, making the transmitter usable in dense wireless environments with frequent and simultaneous transmissions from many devices. Also, the introduction of active rejection avoids the power burden of intermediate frequency overclocking, which overall reduces the power consumption down to 0.88 microwatts, which is the lowest reported to date. As further advantage, this work leads to a fully integrated system with no off-chip power combiner or inductor as opposed to prior art, while allowing unrestricted channel selection. This makes Wi-Fi backscatter transmitters cost-effective, spectrally friendly, and extremely low power for massive connectivity of devices and smart objects. Thank you for watching. Feel free to explore more in our Green IC website.